All right, so welcome back to the series of systems of linear equations. I'm going to go ahead and do this next example. So in this example here, we're still doing this via substitution. So to start off, it's probably easier to write our first equation as x in terms of y. So if we add y to both sides, we end up getting x is equal to y plus 5. And we'll just go ahead and take the y plus 5 now and substitute it in for x into our other equation that we haven't used. So if we do that, you see that we'll have 2 times y plus 5, which is equal to 2y plus 14. And so from here, if we go and distribute our 2 across both terms there, you'll see that we have 2y plus 10 equals 2y plus 14. And of course, if we subtract 2y from both sides, you'll see that 2y's cancel and we have 10 is equal to 14. So here we know that 10 does not equal to 14, so this is a case where we clearly know that this is going to be no solution, because regardless what our x and y coordinates would be, we would see that these two lines would not cross because we have this sort of funny business going on right here. Okay? So because of that, we know that the answer to this system is no solution, which means we have two lines that are parallel to one another. And so the slopes of these lines are the same, but the y-intercepts are different. Okay? So we'll go ahead and move on. So this next example I've worked out. And so the only thing that's different about this one is that we have some decimal numbers in it. Pretty much everything else is the same. Solving this by substitution again, we decide to write x in terms of y. And the only reason we're doing it here is to try to avoid having negatives where possible. So if we add y to both sides here, we get x is equal to 0.1 plus y. And so we take 0.1 plus y, and we're going to plug that into our second equation here. So you see that happens. Take this, plug it in, and see that's where we plug it in at. We distribute our 2 across both terms. We end up getting 0.2 plus 2y minus 3y equals a negative 0.5. And then from there, if we simplify and combine like terms and simplify to solve for y, we see that y is 0.7. So then after that, we take our 0.7, plug it into one of our original equations, and so of course our first one would probably be the easier one to do. We take that, plug it in for y. So we're basically taking this, plugging it in for y right there. And we solve for x, and we see that we get 0.8. So this system is independent, and its solution is at the point 0.8, 0.7, meaning that these two lines definitely have slopes that are different, and thus they intersect at exactly one point, and that one point is going to be the point 0.807. So we have something that kind of looks like this, where this point is actually that. All right, so for our next example, we're going to substitute 2x minus 5 for y. So we just take this, plug it in, and once we do that, you see that this is what we end up having here. If we simplify, combine like terms, we see that we end up having 0 is equal to negative 10. And of course, this is another case where we know that these two numbers are not equal, so thus we have no solution. The system is considered to be inconsistent, and we know that this again is a case where we have two lines that are parallel, meaning that the slopes are the same, but their y-intercepts are different. All right, so now we are going to start doing the systems of linear equations, solving it by elimination. And so with elimination, here we're trying to figure out a variable to eliminate so that we can only have one left. And so, of course, for this first system, it's pretty easy to see that we should eliminate y, since we have a negative 1y here plus 1y. So if we were to add these two equations, that would cancel to 0. 2x and 2x is 4x. 5 and 5 is 10. So we divide both sides by 4 to solve for x. And we see that x would be 5 over 2 because, of course, 10 over 4 would be 5 times 2, be 2 times 2, have a common factor of 2. And that's what that fraction will reduce to. So now that we have that, we know what our x coordinate is. Let's figure out what our y coordinate is. So we can take the value for x and plug it into one of our two equations here. I'm going to use 2x plus y equals 5. Plug in 5 halves for x. And I see that 2 times 5 over 2 is just going to be 5 because these 2's right here, if I can get it to work, reduce to 1. And so thus we have 5 plus y equals 5. And from here, we subtract 5 from both sides. We see that y is equal to 0. So the point where these two lines cross is at the point 5 halves 0. Okay, or 5 halves, if you want to write it in decimal form, is 2.5. Okay, so you can either write it like this, or you could say it's 2.5 comma 0, like that. For our next example, we're going to do this by the elimination method again. And so for here, we could eliminate the x variable, but it's easier to eliminate the y variable in this case. And so here, if we could have a positive 2 in that spot, then all things would be nice there and we can eliminate those y's. So in order to make that happen, what we're going to have to do is multiply our top equation here by negative 2. Okay, so going to get rid of stuff here. And we're going to multiply our top equation by a negative 2. So negative 2 on the left side, negative 2 on the right. Our new system now will be a negative 10x plus 2y equals negative 2. And then we have 10x minus 2y equals 2. We add these equations together. We see that cancels to 0, that cancels to 0, and that cancels to 0. So we essentially have 0 equals 0. When we have the case where we have an equation where both of the numbers are pretty equal to each other, we know that this is going to be infinitely many solutions. And so basically what that means is this line, 5x minus y equals 1, is pretty much the same line as 10x minus 2y equals 2. And if you notice here, the only difference in between the 5x minus y equals 1 and 10x minus 2y equals 2 is that the first equation, well, the second equation, is a multiple of 2 of the first one. Okay, so we know that from how this looks, we have two lines that are essentially the same. So that means they intersect each other at every point on each of the lines. So that's why it's infinitely many solutions. The system is considered to be dependent. Well, the equations are considered to be dependent, and the system is considered to be consistent because it has at least one solution. Moving on to the next example. For this one, we would probably want to eliminate the variable x, just because it's probably the easiest thing to do here. If we had a -2 right there, then we could eliminate our variable x. But of course, we just can't put a -2 there, so we have to multiply the whole equation by -2. So we're going to do just that. So we come here and we multiply. That didn't turn out so hot. So let's try to do that again. So we multiply the left side and right side by -2. Our first equation will stay the same, but our second equation will now change. So our second equation now changes to -2x minus 4y equals -2. We see that our x's cancel, and if we add, we get a -7y equals 2. Divide both sides by 7. We see that y is a -2/7. Okay? So now from there, we can take our y and plug it into either the first equation or the second. I'm going to choose to plug it into the original second equation, which was this one. So if I do that, then here this would be x plus 2 times y, which was a -2/7, equals 1. So from there, we know that 2 times, with 2 divided by 1, oops, let's undo that. So we know that 2 times a -2 is a -4. So 2 times 2/7, or -2/7 is going to be a -4/7 over 1. So now here we can, if we don't like dealing with fractions here, we can multiply both sides of our equation by 7 and distribute. So if we do that, we have 7x minus 7 times 4 over 7 is just 4, because the 7's reduced to 1 here, and that will equal 7. So from there, we add 4 to both sides, cancels, and last thing we do is divide by 7. And so we see that x is 11/7. So this particular system kind of looks like this, where we have two lines intersecting at a point, and that point is at 11/7, -2/7. All right, so for our next example, if you look here, you can kind of tell by the way that this looks that this is either going to be one where we have infinitely many solutions, or we are going to have no solution. If you see here, this looks like everything is a multiple of 3 on the left, but 2 on the right. So if we eliminate a variable, let's eliminate x this time. So if we do that, let's multiply both sides of this equation by 3 and see what we get. So if we do that, first equation is 9x plus 24y equals 15. Second equation remains the same. And if we add these, of course that cancels. So we just have 0 equals 25. So of course we know 0 doesn't equal 25 here. Oops. 0 doesn't equal 25 here. So because of that, we know that this is going to be no solution. And what that basically means is we have two lines that are parallel to one another. So these lines kind of look like this. Just assume that those are two parallel lines there. And we know that the slopes are the same, but the y-intercepts are different.